Hello everyone, thanks for joining my SauceCon 2021 talk. My name is Andy Knight, and I'm the Automation Panda. I love building solutions to testing problems. One of the toughest challenges in testing any type of software product is handling the test data. Now, when I say test data, I'm referring to two different things. The actual data that's live in the product under test, as well as the values used by test cases. As testers, we shouldn't underestimate the challenges involved with handling test data. Good test data is just as important as good testing and good automation. In this talk, we'll deep dive into the relationship between product data and test case data. We'll learn the right strategies for handling both. By the end, you'll be able to manage the test data nightmare in your own test projects. So, let's learn how to do it. Let's say we have an application for a bank to provide loans. The bank could configure this application for many different types of loans, such as a home mortgage, a car purchase, or a student loan. All of the information the bank needs to provide loans must be stored as data in the system. Each loan product is different. It comes with its own rate, maturity, and payment schedule. The bank must also store information about borrowers, funding curves, and profitability targets for all loan opportunities. It's fairly complicated. Testing requires that all data to already be in the system as a prerequisite. We could write a simple test case to exercise the basic application behavior. Scenario: create a new loan application. Given the Chrome browser is open, and the page for myloanapp.com is loaded, when the user creates a new loan application for home mortgage, and the user enters all their personal data, and the user submits the application, then the page displays a success message with a reference number, and the loan application is sent to the bank. Now, bear in mind, a real loan application would probably need several pages of information, but let's keep our example simple. This test case creates and submits a new home mortgage loan application for the user. There are many test data points in this short scenario. Most apparently, all the user's personal info. Also, the type of loan. There's also the record of the loan application that's sent to the bank, and the reference number for it shown to the user. Furthermore, the URL is config info, and the browser type is a test input. Test data is everywhere in this short, simple scenario. Test data is inextricable from the test. Without specific data, this test would be meaningless. Unfortunately, the term test data is ambiguous. We've applied it to both the product data in the loan web app, as well as to the various pieces of test case data that make even the most basic test work. Product data refers to real data living in the software system. For the loan web app, product data includes all the bank's product configurations and lending information. Test case data refers to the data used to define test cases. It may include values to enter into the product under test, inputs to control how testing is performed, or records to retrieve from the product. In the latter case, test case data is a reflection of product data, as values refer to entities existing in the product data. The two types of test data are separate but connected. Distinguishing these two types of data is important to avoid confusion. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage application change? What if a loan is no longer called a home mortgage, but a personal residential loan? That would make the test case break. Compounding breakages cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code. How do we handle both product data and test case data? Are there strategies we can use to avoid brittle dependencies? In this talk, we will explore multiple ways to handle both product data and test case data. Unfortunately, there are no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking strategies that work well for your needs. Let's start with product data. As stated previously, product data is any live data in the product or system under test. In simplest terms, it is everything in the database. Examples of product data include user accounts, administration settings, product customizations, records created by users, and any files uploaded by users. For our example loan app, product data would include user accounts, loan product settings, loan applications, and behind-the-scenes bank data. Data must be present in the product as a prerequisite for most testing. There are two primary ways to get that data into the system. On one hand, you can set up the data before running tests. This would be static data creation. For example, the loan web app could be set up with a set of pre-registered users and a collection of loan types. Test cases, whether they are manual or automated, can presume that the static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or data that is slow to create dynamically. For example, user accounts may need email verification, so it might be easier for automated tests to simply use a set of pre-registered users. Tests will run faster if they can simply reference existing data instead of creating new data each time. However, static data must be maintained. Any changes to static data could impact tests too. Static data may also become stale over time, as data formats are updated or if data is time sensitive. On the other hand, you can set up data during test execution. This would be dynamic data creation. In the example loan test case, the loan application document is dynamically created. The test does not reference an existing loan application. It creates a new one. Dynamically created records avoid the brittleness of hard references to static data. They can be used exclusively by the current test case, protecting them from interruptions by other test cases. The main downside of dynamic data prep is the execution time. It does slow down tests. Dynamically created data is essentially disposable too, so it should be cleaned up eventually. Which strategy is best? Typically, testing requires both strategies together. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data, and there's a much lower risk of test collisions. These two data prep strategies are a bit complicated when implementing them. Dynamic prep depends directly upon the test cases using it. However, static prep has a few general strategies that are independent of the test cases. The simplest data prep strategy is manual configuration. That's exactly what it sounds like. Testers log into the system and manually create whatever records need to be in the system. That could include creating users, configuring settings, and saving records. The nice thing about manual configuration is that it's low-tech. Anyone can do it. It doesn't need fancy or complicated tools. However, manual configuration is slow. It does not scale well for large systems or large test environments. Furthermore, manually configured systems can easily fall into disrepair without any automated mechanisms for maintenance. A better strategy might be automated configuration. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways: reusing UI interactions from tests, calling REST APIs, or even possibly using tools like Puppet or Chef. Automation could generate test data deterministically or randomly. The main benefit of automation is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive values. Unfortunately, automated configuration is not a free lunch. It requires extra skills and code must be maintained. If you want a shortcut, you could try to clone the databases. Cloning databases is easier than ever with cloud management tools. You could maintain one database in a quote-unquote golden state and then create a copy before running tests. Once testing is complete, the copy could be deleted. Granular cleanup would not be necessary. Database clones make it easy to copy all data at once without worrying about any damage that rogue testing could cause. However, databases can have a lot of data, so cloning large ones may not be practical. Clones may also need extra refinement to scrub special fields and hook them up properly. Finally, if managing real data is too much of a hassle, then you could mock endpoints. This would completely remove dependencies on database and even services. All data returned by the mocks would be deterministic too, yielding consistent results. However, mocks are not always a good solution. They often require a lot of effort to set up, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that tests would not truly be end-to-end in coverage. These strategies can also work together. For example, you could use automated scripts to configure product data in a golden database, and then you could make clones of that database. In another example, in a large testing environment, you could choose to mock some endpoints while using real data for others. There are multiple factors that should be considered when deciding the best strategy for static data prep. How big is the data? If it's small, then manual configuration may be sufficient. If it's large, then automation may be required. How fresh does the data need to be? If data is time sensitive, then automation will need to keep it up to date. How frequently will data need to be updated? Again, automation can help for frequent updates. How difficult will it be to try advanced tricks like mocking or cloning databases? This may be especially difficult for old or legacy systems. Is there any bureaucracy in the way of automated solutions? Hey, it happens. Not every organization has an efficient or even a healthy culture. Bureaucracy can stonewall advanced solutions that need extra support. Do folks have the skills required for automation, database administration, or mocks? Skill level may be a barrier at first, but training and learning can help teams overcome any limitations here. And finally, what about the cost? Each data prep strategy has a cost. Teams should do a cost-benefit analysis when deciding. So, that's how to handle product data. What about test case data? Let's look at that next. Test case data is inherently part of test cases. Let's revisit our example test case from earlier. As we saw before, There are multiple bits of test data throughout the steps of this short scenario. They represent different types of test case data. First, let's look at the first step. Given the Chrome browser is open. The Chrome browser is test data because it specifies the type of web browser in which to load the web app. This is what we call a test control input. It directs how tests will be run rather than specifying feature behavior. Theoretically, this test should run the same on any browser type, but the steps dictate that the test should run on Chrome. As a best practice, test control inputs should not be hard-coded into the test automation code. Instead, they should be passed into automation as inputs. That way, the test can easily be retargeted. There are a few ways to do this. The simplest way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they are easy to write, easy to read, and easy for programming languages to parse. They can also have line-by-line diffs. Test automation code can read the file before any tests start, and it can inject input values as appropriate. For example, using this JSON file, automation could read this browser type and construct Selenium WebDriver objects for Chrome for each test. The path for the input file would need to be hard-coded into the automation, but it could be as simple as a standard file name in the current directory. Another way to handle inputs is using environmental variables. Testers could set variables from a system shell or profile, and automation could read those variables by name. This could be useful for integrations with continuous integration servers or Docker containers. However, it can be a little more dangerous because anyone could change variable values. Again, automation can read these variables before tests run and handle them appropriately. Let's remove that hard-coded step for browser type from the test scenario. That can be handled as an automation concern. Next, let's look at the second type of test case data. Notice how the URL is hard-coded. This is also not a good practice. Typically, development teams host multiple instances of products under development, like a developer environment and a staging environment. Hard-coding configuration information like this limits where tests can run. Any information about a product's configuration is called configuration metadata. This can include things like URLs, usernames, passwords, and possibly other descriptors. There are a few ways to handle config metadata. You can use flat files or environment variables like you do for test control inputs. However, I recommend using flat files, and I also recommend separating test control inputs from configuration metadata. Create an input to refer to the target configuration, and store multiple configurations in the config metadata files. That way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you could create a web service to provide config metadata. This would be especially helpful for keeping secrets like passwords safe. However, creating such an endpoint may be overkill for your needs. Either way, the test step can be rewritten to refer more generically to the web app. Automation can select the target environment using the inputs and config metadata. The remaining pieces of test data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. The first kind of test case data value is a literal value. These are values that are hard-coded in the test. In this example test, the table of personal info contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into the web app. Theoretically, these could be any values. The second kind of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they are the outputs generated by exercising a behavior. In this example test, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify that it was correctly submitted. These values cannot be literals because they originate from the product. Tests must refer to them by reference and retrieve their values from the product. As a side note, this test dynamically creates the loan application. This is an example of dynamic product data preparation that we covered earlier. The third and final kind of test case value is the trickiest, the input reference. At first, these may look like literals. However, input references are any values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, this test has an input dependency. It must specify the type of loan, and the loan type must already exist in the product data. The simplest way to write this test is to simply hardcode the reference. That's what is done here. The name Home Mortgage refers to the name of the loan type in the web app. Automation can use that name when selecting the loan type from a button or dropdown. Hard-coded references make it easy to write tests, but they require statically prepped data to exist in the system. References also become hard to maintain when the product data changes, or when the same test must run against different configurations with different names. One way to avoid the pain of static data is to dynamically create these records or configurations. If the test calls the back end to create a new loan product named Home Mortgage for each test run, then static pre-prep isn't needed. However, we already know the pain points of dynamic prep. In this case, let's say dynamically creating a new loan type is just too slow. A more robust solution could be data discovery. Let's say the target web app is already configured with multiple acceptable loan types. Instead of hard-coding the name of the desired loan type, the test could describe the loan type and then use automation to search the web app's config to find a loan type matching the desired criteria. For example, if different regions of a bank have different names for this type of loan, the discovery mechanism could look into the config for a satisfactory home mortgage loan and return the specific name for the current bank region. Discovery enables tests to search existing product data for required records instead of hard-coding those records. Discovery makes tests more resilient to changes in product data. It's great when testing multiple environments with ever so slightly different configurations. However, it requires extra coding, and it may be overkill for small projects. That's a lot of info about test case data. In summary, test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configuration for the target environment. They should be supplied via config files or service API calls. Test case values direct the behavior covered by the test. They may be literals, output references, or input references. Input references may be hard-coded or discovered. At this point, you're probably thinking, wowza, that's a ton of information. But that's it, right? We're done, Is it time for Q&A? Well, frightfully, the nightmare isn't over. There's one more problem to address. Collisions. Collisions can happen whenever multiple actors operate on shared resources. For example, they could happen whenever multiple testers simultaneously access the system or when automated tests run in parallel. Additional considerations must be taken to avoid collisions. First and foremost, isolate the test environments. Prevent external actors from interrupting tests. If you have a shared test environment, block other folks from accessing the system when tests are running. You might need to schedule tests to run during off hours. You might also want to set up multiple test environments. If the product under test is containerized, or if databases are clonable, then you could easily dynamically create fresh environments for each test launch. That would guarantee perfect isolation. Secondly, treat any shared data as immutable. Sometimes, shared product data is unavoidable. For example, if tests run in parallel against one test environment, they may use the same product data. Or if an application has multiple components, certain components may be difficult to isolate for testing. Whenever data must be shared, treat that data as constant. Any changes to shared data could break tests. For example, one test might require a car loan, but another test might delete the car loan type from the bank's configuration. Any tests that must alter shared data should be run serially instead of in parallel, and they should always undo any changes they make. Third and finally, use dynamic data preparation as much as possible. Tests cannot collide on data they don't share. Keep statically prepared product data to a minimum. Statically created data is more likely to become shared data, and shared data is more likely to cause collisions. Boom! We covered a lot of material in half an hour. So let's recap what we learned. There are two primary types of test data: product data and test case data. Product data can be prepared statically or dynamically. Test case data either control how tests run or reflect product data. Handle references and shared data carefully. And overall, choose the best strategies to defeat your nightmares. Every product is different, and every team is different. Take the strategies I shared in this talk as suggestions. Thank you all so much for listening to my talk about test data. Again, my name is Andrew Knight, and I'm the Automation Panda. Be sure to check out my blog and follow me on Twitter. I hope you enjoy the rest of SauceCon 2021.